Hi there. Look who's back. Yes, it's me back from everywhere. We went everywhere. Anyway, I won't bore you with all of that. Andrew Dunkley here. Great to have your company on another episode of Space Nuts. And coming up on today's show, we will be diving into the weird world of Exo-Asteroids or Exocomets or whatever they are. 31 Atlas to be exact. And it turns out it's a bit of a strange one. Also, InSight. The InSight mission is unraveling Mars's secrets, particularly its deep, dark past. And believe me, it's a little bit ugly. And a galactic habitable zone. Is there such a thing? What does it mean? And what are we going to find there? We'll find out on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to do all the unraveling is Professor Fred Watson, astronomer at large. Hello, Fred.
Welcome back, Andrew. It's a treat to see your smiling face there.
It's a treat. It's a treat to be back and doing this after it's been 3 months. I can't believe that it's been. Judy and I were only saying today we cannot get our heads around the fact that we're away for 3 months because it doesn't feel like it. It's just, it went so fast. But gee, we had a good time, Fred. We had an amazing time. Unfortunately, did not get to see the Northern Lights, and that was one of my. But I might get another opportunity. It's not the last time we'll go away somewhere, so fingers crossed. But even as far north as North Cape, the northern tip of Europe, right up inside the Arctic Circle, did not see a thing. Probably because it was nearly daylight every minute of the day and night, so that doesn't help. Nope. But yeah, a terrific holiday. I wouldn't know where to start to tell you about it. I know I posted a lot of pictures that people saw every time we went away or went somewhere. But just saw some amazing things, met some amazing people, had some amazing moments, just little things that we didn't expect, like the captain of the ship suddenly deciding at the last minute to take us up Prince Christian Sound in Norway, which is somewhere where not many people get to go. And the only way to get there is by ship. And it is full of icebergs and wildlife and just glacier after glacier after glacier right there in front of you. It's indescribable. It's just the most amazing scenery. We sat up on the deck for 7.5 hours straight, just taking it all in. We did not move. It was that captivating. That was one of the highlights. Namibia was amazing. Loved Namibia. We loved Scotland, loved Edinburgh, Fred. What a terrific place. We had porridge for breakfast.
And you had haggis for lunch, didn't you?
And had haggis for lunch, which was surprisingly nice. You hear horror stories, but it was actually quite tasty. Really enjoyed it. And look, the countries we visited were many. The highlights were numerous. I could talk for hours, which probably wouldn't work well on a space podcast. So I won't say too much more about that. Although at Tenerife, we did see the observatory up above the snow line there, above the tree line, actually, not the snow line. Yes, you drive up the hill, you've probably done this, Brad, and all of a sudden there's no vegetation. It's just gone. Yeah. And there's an observatory up there, which is primarily a solar observatory. So
that's right.
Yeah, got to have a...
So Teidi's the name of the mountain.
Teidi, that's right.
Yep.
Yes. But here we are, back again.
I do have a question for you about your tour, Andrew. Did you run into any space nuts?
I did. I actually did. One in particular who I ran into in a toilet on a ship, on our cruise ship. I was walking out and he said, are you Andrew Dunkley? And I went, yes. He said, I'm a Space Nuts listener. He said, and I remember he did message me to say he'd be on the cruise and getting on in Dover, and I'd forgotten about that. And we ran into each other in passing. So, and as always, I've forgotten his name, and I apologise for that. But it was nice to catch up. So yes, we did run into a few people I did pass or speak to on the ship knew me, but I don't know if they knew me from radio or from the podcast. We never really clarified that, but yeah, it was quite extraordinary. But if you jump on Facebook, all my photos are on my Facebook page and Instagram, so you should be able to see most of what we did. So I don't take up the rest of the show talking about it. Although I'll probably have times where I'll make references to things we saw and did, and yeah. Now, we got a lot to talk about, but one of the things you do want to discuss, and I think you did that with Heidi. Oh, and I'd like to say just my sincere thanks to Heidi for stepping up and covering the last few months. It was a big job, and she did fantastically. The feedback I've been getting, even while I was away, was glowing. So well done, Heidi, and thank you, much appreciated. And you talked to her last week, and you want to mention again, the Australian Dark Sky Alliance is looking for some support.
That's right. So if you're not either a resident in or a citizen of Australia, you can zone out for a minute while I talk about a petition which the Australasian Dark Sky Alliance is trying to get put up to the federal government, the government of Australia, in order to put legislation in place to limit light pollution, to actually restrict it as an environmental issue, not just for astronomers, but for wildlife, for human health, all of the above. So if you do fall into one of those categories, the place to go is their website, which is all one word, australasiandarkskyalliance.org. And so australasiandarkskyalliance.org will take you to their website, which on the front page has instructions on how to sign the petition. And you've got till September the 19th. And thank you for that plug, Andrew.
My great pleasure. And hopefully the politicians will listen. Hopefully you get the numbers. That's the most important thing. Yeah.
That's right. That's the
and it's a really important thing. I mean, we've talked about light pollution many, many times over the years, and it's just one of those growing problems, which doesn't seem to get a lot of attention because no one really thinks about it as a problem. I suppose that's the problem.
It is. On the other hand, it is one of the easiest to fix because a flick of the switch actually does it. But you're right. I mean, there's certainly regulations in regard to noise pollution. And of course, every other kind of pollution. We're seeing regulation coming in on plastics pollution, but light pollution is the orphan pollution at the moment, and it's an important one. It's one that's more important than most people realize. And one statistic, you might not be aware of this, Andrew, but light pollution is increasing globally at 10% per year. So that comes from citizen science. Yeah, we know that the stars are disappearing at that rate, 10% a year. It's very ugly indeed.
That's not good at all. And having witnessed now 24-hour-a-day sunlight, I do understand how it can mess you with your brain. So it's not good for human health. So that's australasiandarkskyalliance.org, 10,000 signatures by the 19th of September, if you will. Right. Our first topic, Fred, takes us into the realm of interstellar objects, 31 Atlas. Now, I did see this one pop up in the news while I was away. I did try to keep in touch, but when you're moving into different time zones at different parts of the world, your news suddenly changes, which is a little bit weird. But 31 Atlas, this one was only a recent discovery, and it's hammering its way through our system as we speak. But they've been able to analyze it thanks to the James Webb Space Telescope. And this one's a little bit unusual.
That's right. And because all the text you've read is in Arial font, you wouldn't have no way of knowing that it's actually 3I Atlas. Because 3I being the third interstellar object to pass through the solar system. And Atlas, of course, the name of the facility that discovered it.
I'm using jet lag as an excuse.
It doesn't matter. Even if you weren't jet lagged, you wouldn't have known, because
No,
it's exactly like one Atlas.
31.
Yeah, but it's 3i. Never mind. You see, that's the advantage of Times New Roman. That would solve the problem. Anyway, it is being observed as it flies by the solar system. It's closest to the sun, if I remember rightly, on the 29th of October. So unlike Oumuamua, which was one eye, the first interstellar object, we didn't catch up with that until it was on its way out of the solar system. Atlas, we found on the way in, and one reason for that is that it's a much bigger object. I think the best estimate we got for the size of Oumuamua was something like 40, maybe 100 meters long, something of that sort. I can't remember the exact number. But this thing is thought to be about 20 kilometers across. Wow. And it's, despite the prognostications of Avi Loeb, who wanted it to be an interstellar spacecraft, it's behaving exactly like a comet in that it's as it approaches the sun, the material that it's made of, which is a mixture of ice and dust, that heats up. The ice turns into a vapor, the dust gets released, and it generates what we call a coma. Coma is just a word meaning hair, and it's a sort of fuzzy bit of the comet, and it develops a tail. And indeed, 3i Atlas has done that. It's what's of interest, of course, is that there are mixed in with the dust. There are atoms and, in fact, molecules of the material that binds it together, the ices that bind it together. And it's not just water ice. We know that comets are made mostly of water ice. Water, as we've said many times on Space Nuts, is the most common two-element molecule in the universe. So it's natural that we should find water in comets. But there's also basically carbon dioxide, CO2, carbon monoxide, CO, and those gases are revealing their presence by their spectra. The rainbow spectra that you can analyze, the light that's coming from them. And indeed, exactly as you've said, the James Webb Space Telescope is being used by a number of authors, mostly in the United States. Goddard Space Flight Center and the Catholic University of America are two of the organizations represented. So you've got carbon monoxide, carbon dioxide, you've got something called carbonyl sulfide. All of these are not unexpected because that's what we find in comets that belong to the solar system. But here's the rub. It's the ratio of these molecules to each other that is the peculiarity of 3i Atlas. And in particular, the ratio of carbon dioxide to water is actually 8:1. So 8 parts of carbon dioxide to 1 part of water. And that's higher than any other comet that's ever been seen and way, way above the normal value, which is, I think, 2 or 3:1, something like that. I can't remember the exact number. However, carbon monoxide has a ratio with water that's more or less the same as solar system comets. It's 1.4. So there's a puzzle. Why is the carbon dioxide so much more abundant? And of course, as always, when faced with a puzzle, astronomers start trying to work out what's going on. And they basically think that they have sort of solved it. It's one possibility is if you imagine the host star system in which this object was created, and it would have formed like the solar system's comets, probably in an Oort cloud like the one we have around our solar system, which is made up of cometary bodies, which eventually fall in towards the inner solar system, and that's when we see them. There's a suggestion that if you've got very high levels of ultraviolet radiation from that host star, and that would be the case if it was a young and very massive star, that apparently could change this ratio of water to carbon dioxide. And another comment that's been suggested is that maybe it's a part of that of the solar system in which it was born that's a long way from the host star and above the host star's carbon dioxide ice line. So beyond a certain distance, you get more carbon dioxide in relation to water. And that's another possibility. There's several more that are being thought of, but the bottom line is, nearly as always with stories like this, Andrew, what we need is more observations. We don't have very long before it will get too faint to observe. It'll be probably next year when it starts really disappearing out of the solar system. But so we've got this golden opportunity to analyze it and investigate it, and that's exactly what's happening.
How visible is this one going to be as it reaches the inner sanctum of our solar system?
Yeah, not that visible because, in fact, I don't have a figure for its magnitude, the gobbledygook number that astronomers use for brightness. But it's certainly very much the province of big telescopes. The thing is, its nearest approach to Earth, I can't remember. It's more than one astronomical unit, I think, which is the distance between the Earth to the Sun. I can't remember the exact distance. It's not that close to the Sun either. And I think I'm right in saying that when it's closest to the Sun, we can't see it because it's in the same direction. It's sort of passing behind the Sun. That was one of the comments that Avi Loeb made, suggesting that maybe when it was at its brightest, its orbit had been chosen so that we couldn't see it when it was at its brightest. And the other thing he pointed out was that it passes very close to, or close-ish, to Venus, Mars, and Jupiter. The suggestion was that there might be intelligent design behind that. But I think he's the only person in the astronomical community who thinks that.
He might be right. You've got to give him credit, though. He's always...
Absolutely. Yeah, we need ideas like that. Absolutely.
Yeah. Okay, so and is this one honking along like the others at a greater rate of knots?
60-something kilometers per second, which is kind of one of the things that tells you that it doesn't belong to our solar system. It's going too fast.
Right. There you are. Okay. You can read up on that one at universetoday.com. 3i Atlas. Got it. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Let's take a moment to talk about our sponsor, Insta360 Go Ultra, a pocket-sized camera that's redefining how you capture life's adventures. Imagine a camera no bigger than an Oreo, weighing just 53 grams. It's small enough to slip into your pocket, but delivers professional-grade footage that'll make your vlogs, travel diaries, or family moments look absolutely stunning. The standalone camera is IPX8 waterproof up to 33 feet, so whether you're surfing, swimming, or caught in the rain, it's ready to roll. The Go Ultra's upgraded sensor and AI chip ensure your shots are crisp and vibrant, day or night. Battery life? The Go Ultra's got you covered with a next-gen stacked polymer battery. The standalone camera runs for 70 minutes, and when paired with the Action Pod, you get up to 200 minutes of shooting time. Need a quick recharge? Plug it in, and it hits 80% in just 12 minutes. Enough time to grab a coffee and get back to creating. And if you misplace your camera, Apple Find My Compatibility has your back to track it down. Storage is a breeze with removable microSD cards supporting up to 2 terabytes, so you can shoot to your heart's content without worrying about running out of space. Here's the best part. For the first 30 Space Nuts listeners who purchase the Insta360 Go Ultra at store.insta360.com, you'll score a free sticky tabs accessory to mount your camera on anything from backpacks to winter jackets. Just use the promo code SPACENUTS at checkout. That's store.insta360.com, promo code SPACENUTS. Check the description for links and more details. Don't miss out on this tiny titan of a camera that's ready to capture your world like never before. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Our next story, Fred, takes us to a place I rarely mention. It is the red planet Mars. InSight has been sort of examining some of the secrets of Mars and come up with new information that kind of might surprise people about Mars's deep, dark, and ugly past. There's been a few revelations.
They have, yes. I mean, InSight is the gift that keeps on giving, really, because it switched off in 2022. It's a spacecraft that landed near Mars's equatorial region. I think in about 2019 was when it touched down. And you might remember we discussed a lot the instruments that are on board it, because one of them was a seismometer, which has been incredibly successful. And the other one was the interior thermometer, which was incredibly unsuccessful because they were trying to drill a hole to put this thermometer down under the surface of Mars. And I can't remember what happened. The drill kept breaking or something unsatisfying happened. And so that part of the experiment was not as successful. But the seismograph has done its job. And the results from that keep on being reanalyzed because as time goes on, we've got many more analytical facilities at our disposal, which we didn't have before. And you can now look at these seismic records with a lot more meaning. And what's been discovered, it's actually from an analysis of 8 seismic events, which two of which were probably caused by meteorite impact on Mars. You remember the two mechanisms, because Mars doesn't have plate tectonics, it's a single crust. It's stretching and shrinking of the crust and sort of rift valleys forming and things like that give you the seismic events or meteorite impacts. And two of those seismic events, as I said, were meteorite impacts. But it's the way that the relative frequencies of the vibrations, these seismic vibrations, the relative frequencies of these, that allows people to basically examine the interior of Mars in a very intelligent way. So you look for higher frequency waves compared with low frequency waves, and basically that tells you about the length of transmission time for these different waves, how long it takes you to get from the site of impact, wherever that is, to the seismograph. And one of the authors of this work, I think there's certainly authors at Imperial College London and other institutions, but one of the authors made a comment which I liked. These signals show clear signs of interference as they travel through Mars's deep interior. That's consistent with a mantle full of structures of different compositional origins, leftovers from Mars's early days. And what that means is, so the mantle is the region between the crust of Mars and its core, its hot core. We've got a mantle on Earth. I think Mars's mantle is rather deeper than ours relative to the diameter of the planet. But what they've found is that the mantle isn't a sort of uniform paste of semi-solid rock, but it has structure in it. And that structure is thought to come from events that took place during Mars's origins. And in fact, what they're suggesting is that when Mars was being formed about 4.5 billion years ago, it was at a time, as we've talked about it before, not long after that, there was the the late heavy bombardment, when there was a lot of stuff careering around the solar system, big objects the size of mini planets, really, banging into everything else. And the suggestion is that at that period, some of these planetoids or planetesimals actually collided with Mars and basically melted parts of Mars into oceans of molten magma. And then you find that these regions cool, but when they're cooled, they have a different structure from the stuff that didn't get clouted and melted by an impact. So what you're doing is you're differentiating between different zones of Mars's mantle. And what they're saying is that what they're detecting with this inhomogeneity in Mars's mantle is evidence of these, what they describe as compositionally distinct chunks of material. Mars as mantle has got some bits that were never reheated and others that were reheated after the planet's formation by these collisions, probably molten, then they hardened and they crystallized, and that gives you a different structure, which is what's now been seen. So it's, one of the comments, the same author who I just mentioned, most of this chaos likely unfolded in Mars's first 100 million years. And the fact that we can still detect its traces after 4.5 billion years shows just how sluggishly Mars's interior has been churning ever since, unlike the Earth's, which is much more active. So the Mars story from InSight keeps on amazing us. We keep discovering new facts about it, and long may it continue, Andrew.
Yes, hopefully. And there's so much more to learn. And this is what I love about these inner planets and the outer planets as well. The more we look at them and the more we analyze the data that we're receiving from various missions, the more interesting they get and the stranger they get sometimes, as is the case with Mars in this particular situation. So, it's a fascinating place. Cosmosmagazine.com is where you need to go to find out more about that if you'd like to follow up on that story. Andrew Dunkley here, Fred Watson there. You're listening to Space Nuts.
0G, and I feel fine.
Space Nuts.
And our final story today is about a galactic habitable zone. Now, we know about the habitable zone in our own solar system, which is affectionately called the Goldilocks zone. And we know about that because we're in it. It's the only thing that keeps us alive, really. And but Fred, my question first up is, are they talking about a Goldilocks zone on a galactic scale? Is that what this is?
Yeah, effectively, but it's not the temperature that's not too hot and not too cold, but just right, as it is in our Goldilocks zone. The temperature's just right at this distance from the sun for liquid water to exist, and we know it does because we see it pretty well every day in our reservoirs of water, whether they're a bathtub or a sea. But that's not what the Galactic Habitable Zone is about. And it is being called that, the GHZ or GHZ, if you're on the other side of the Pacific. It's a region where you might expect to find more habitable planets than nearer to the center of our galaxy or further or further out towards the edge of the galaxy. And it basically comes about because you can analyze, we know a lot about the way stars evolve. And we know a lot about the chemicals that have basically been found in stellar interiors and their atmospheres. And we can trace this history of stars very accurately. And we can also look at the orbits of stars around the center of our galaxy, and we can work out to some extent where they've come from, because we think that the orbits of stars actually change in a process called stellar migration, where stars' orbits change around the center of the galaxy, and you can find that they move. And so one of the studies, comments that's come from this particular study, it's actually an international team of scientists who have looked at this. This is published in Astronomy and Astrophysics, one of the main learned journals of astronomy. What they've discovered is that there's a 5 times greater likelihood of stars migrating from one part of a galaxy to another for habitable planets, for stars that have habitable planets, compared with a lack of any stellar migration. So this is a slightly obtuse thing to look for. But what it says is, it's all about, for example, whether you are in a part of the galaxy where your solar system could host gas giant planets, because they would basically have an effect on the formation of the kind of rocky planets that we think are the habitable ones. So I might just read a quote from this paper. It's a little bit technical, but I think it's an interesting quote. It sort of illuminates what we're talking about. In this study, we have significantly expanded the exploration of the parameter space defining the galactic habitable zone compared to previous analyses present in literature. Our findings are particularly relevant in the context of upcoming space missions, such as the ESA Plato mission, that's planetary transits and oscillations of stars, the ESA aerial space mission, and large interferometer for exoplanets, that's LIFE, LIFE. And these missions will deliver unprecedented data on planetary properties, orbital architectures, and atmospheric compositions. So what they're basically saying is, if you're going to look for habitable planets, you want to be careful where you look, because if there is such a thing as a stellar or a galactic habitable zone, then we want to be looking there if we're going to look for habitable planets. It's an old idea, actually. The GHZ or GHZ goes back to the 1980s, and it's all about the formation of the heavier elements, the ones that are basically work like iron, silicon, oxygen, all of these elements. You've got to form them. You've got to form them in the right place in the galaxy, and you've got to then let that environment breed these elements into molecules, which basically become the precursors of life. I'm sorry, that's just the gobblebook explanation.
No, fair enough. So does that mean that in our ongoing search for exoplanets, we should be focusing on the GHZ areas? Or do we not really care where the exoplanets are? Finding them is imperative regardless.
Yeah. No, that's exactly right. That's exactly what these authors are saying. We should be looking in the right place if we want to find habitable planets. And indeed, the Plato mission, for example, is going to look at 1 million stars. It's a bit like Kepler, the Kepler mission. It's finding planets by transits. So that's going to scan 1 million stars, and you want to make sure you're looking at them in the right place. That's the bottom line. Yeah.
Although some would say, well, if we focus only on those areas, we might miss something important in the not so habitable zones. You just never know. But,
and part of the problem with that is that we've only got one example of life, and that's here on Earth. And so we're sort of looking for the same kind of chemical reactions that formed life here on Earth to form similar life elsewhere. But there might be other kinds of life that don't need those reactions.
Yeah. It's funny you mentioned that, because it just reminded me, while we were on our cruise ship, we played a lot of trivia, because, that's what you do. And one of the questions that came up was, I can't remember the wording, but they basically wanted you to explain what the Drake equation was. And I think only 2 of us got it out of 200 people. I was very proud of myself, actually.
I'm sure you will be. Yeah, good on you.
Okay, so if you want to find out more about the galactic habitable zone, you can do that through the universetoday.com website. It's a really interesting article too. I did manage to read the first paragraph. Now, one thing I wanted to mention when you were talking about InSight and Mars not having tectonics, I meant to add this onto the end of that segment, but I'll do it now. While we were overseas, we went to Iceland, and what an amazing place Iceland is. We got to walk along a rift valley where the Eurasian tectonic plate and the American tectonic plate meet. You can actually walk along it, and the American plate is going up and over, the Eurasian plate is going down and under, and you can walk right on top of that. And you're walking along thinking, isn't this amazing? And then you start seeing the plaques that explain, well, this was an earthquake in 2011. Yes. This was an earthquake in 2015. And you're thinking, why am I standing here?
Actually,
quite incredible.
So the place you were at is a place called Dunkley. It's in not that far from Reykjavik, but it's not plates colliding; it's plates dragging apart because you're in the middle of the Atlantic. Yeah, so they're separating. So you need to be even more careful because if they separate a bit faster on the day you're walking through it, you're going to drop right into the hole.
Yeah. Well, there are a lot of cracks in the ground in that part of the world.
Yeah.
So it does make sense.
Yeah.
I must not have read the literature when they explained what was happening exactly, but I thought they said colliding. So
it's coming apart. It's the Mid-Atlantic Ridge that is the only place where the Mid-Atlantic Ridge is on the surface, and Dunkley is where it's most obvious. There is another place not very far from there. It's actually on the Reykjanes Peninsula to the west of Reykjavik, and there's a bridge across this border, and you can stand on one side of the bridge and you're on the Eurasian plate, you stand on the other, you're on the American plate. And all the locals think it's a great joke because, there are things like this all over the island, basically the island splitting in pieces because of that separation. But I saw photos saw photos of people doing that, but we didn't go there. But we went to a lot of places in Iceland, but one of the things we learned about a lot in places like Iceland and Greenland and up in northern Europe was how fast the glaciers are melting. Yeah,
and
shocking.
It is very shocking. Some of them are losing 20 meters or 200 meters a year, I should say, which is staggering. And that's lost forever. We can't reverse that. So it is rather shocking. In fact, we were, I think it was when we were in the St. Christian Sound, Prince Christian Sound. They were saying, see that rock in front of that glacier? And we all went, yeah. Well, it was actually covered in ice 2 years ago.
Yeah.
That's how bad it's getting. And this is just this rock in the middle of nowhere, and the ice is way, way, way back. So, yeah, pretty shocking stuff. That's just about it, Fred. Thank you so much.
It's a pleasure, Andrew. It's great to welcome you back. And I look forward to continuing the recordings at a time that you don't have to choose between awkward times on different sides of the planet, which is what we could do. Heidi and I juggling our respective days.
It's a bit difficult with those time differences. Well, while we were on the ship, we sold and bought a house, which in the early phases was simple because it was only a few hours time difference. But when it got to the real crunch of, settling it all, the time difference was 12 hours. So it really got difficult. But it's done now. And yes, we're in our new place. I should show it to you. I've got the Yankees Red Sox baseball game background on because I took that photo when we went and watched a game in New York the other day, which was a lot of fun, and the Red Sox won. Whoops! I'll put a normal background on so you can see the new place, which pretty much looks the same as the old place. But anyway, whatever. Thanks, Fred. We'll catch you real soon.
Sounds good. Thanks, Andrew. Take care.
You too. And don't forget, if you would like to support the Australasian Dark Sky Alliance and get those signatures on their petition, it's australiandarkskyalliance.org, and just follow the prompts for Australian signatories only. Australasiandarkskyalliance.org. That's it from me. And, I forgot to thank Here in the Studio, which I quite often do. From me, Andrew Dunkley, thanks for your company. See you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.